Good afternoon, everyone. My name is Buma MT. I'll be presenting integers part 1 for today. Now, the first thing that we need to know, I have been saying this for a long time, the definition. What are integers? Integers are whole or natural numbers and they are negatives. Moving on, we said integers are whole or natural numbers and they are negatives. Now, let's look at the number line that represents integers. If you look at this number line, you've got negative and positive numbers. And now, remember that we said integers are whole or natural numbers with their negatives. If you look at these numbers, starting from 0 to 6 in your real number system, you dealt with whole numbers, and you said this set was a set of whole numbers. But if we start from 1 only and moving on, that would be the set of natural numbers. Now, you look at these, I said they are integers are whole or natural numbers with their negative numbers. We have negative numbers on this side. Now, there are your integers. Your integers are this whole set of numbers. Moving on, there is a very important key concept to remember. That is why I'm saying to you, always remember this when you are working with integers. Now, when you are multiplying integers, keep in mind that when you have a positive number multiplied by a positive number, the product will always be positive. When we multiply again, a negative number multiplied by a negative number will also give us a positive number. A negative multiplied by a positive will give us a negative number. A positive number multiplied by a negative number will give a product of a negative number. Please always remember that when you are multiplying integers. Now, what about division? When we divide integers on that side there, when you divide a positive number by a positive number, the answer becomes positive. When you divide a negative by a negative, the answer becomes positive. That is why we always say multiplication and division are actually cousins. They go hand in hand. When you divide a negative by a positive number, the answer comes out as a negative number. When you divide again a positive number by a negative number, the quotient, which is the answer, would be negative. I hope that you have noted that. As I said, always remember this. This is very much important. Now, let's take examples and see how these are working. Number one, I'm going to be using addition and subtraction as mathematical operations of integers. We are revising the previous work that you have already done in your class. We have to calculate -6 minus into -8. Now, if you look at that, we have two signs between the numbers, and mathematics does not allow us to do that. Now, the question is, What must we do in that situation? You have to multiply these two signs so that they give you one sign. Remember, we said that a negative multiplied by a negative is a positive. Let's move on to the next step. Do you see there that we still have got that negative in front of a 6? But now here, because I have multiplied the two, I have a positive. Now I have a negative 6 plus the 8. What happens when we are adding and the signs are different? What you have to do is you subtract and take the sign of the bigger number. In this case, the bigger number is 8. Now, when I subtract 6 from 8, I get a 2. But now that 2 must take the sign of the bigger number, which is positive. There's your answer. Please note that if we don't indicate the sign in front of the number, that means that that number is positive. Moving on, we have negative 6 minus 4 minus 3. Remember, in the previous problem, we said that when we have different signs, we subtract and take the sign of the bigger number. Now, what happens when you have a common sign? When you have a common sign, you add all your numbers and take that common sign. In this case, I'm just going to say 6 plus 4, which is a 10. 10 plus 3, which is 13. Now, my answer is going to be 13, but now remember the sign is negative. That means that my final answer has to be negative 13. I want to repeat this. When the signs are different, subtract and take the sign of the bigger number. When the signs are the same, you add and take the common sign. Let's see what happens when we multiply and divide integers. Now, in this example, we have to determine the value of 5 multiplied by a negative 4 multiplied by a 2. Remember, when there's no sign there, it means they are both positive. Now, you have to remember what I told you about multiplication and division of signs. Remember, when we multiply a positive by a negative, we get a negative. When we multiply a negative by a positive, we get a negative. Now, 5 multiplied by 4 is 20, and 20 times 2 is 40. In this case, our answer, because we have been multiplying positives and the negative, would come out as a negative. There we have it, beautiful. Next example, look at this beautiful example now. We have 100 divided by into negative 25 divided by negative 5. Folks, always remember your bottomers, please. In this case, I would deal with that bracket before any other thing. And I would remember what my teacher told me, that when I divide a negative by a negative, I get a positive. Now, it means that in this case, I'm expecting the answer here to be beautiful, positive. Now, 25 divided by a 5 is a 5. There we have it, a 5. Now, if you look at what I have done here, I have actually dealt with that bracket. Negative divided by negative is a positive, beautiful. How many 5s are in 25? We've got 5 of them, and they are positive in this case. Now I can actually divide 100 by that positive 5. There you go. You see where the positive 5 comes from? I can hear everyone saying, yeah. The answer would be a positive 20. Beautiful. Next example, Now we are calculating integers with all 4 operations in mathematics. 4 operations, I'm talking about addition, subtraction, division, and multiplication. We have to calculate into minus 12 divided by 3, close bracket, divided by, into 6 divided by minus 3. Now, keep in mind that in your previous grade, we said when we divide fractions, we change the division sign into multiplication sign. That is the first one. Next, when you divide a negative by a positive, you get a negative. When you divide a positive by a negative, you get the negative. Now, let's work this out. You see there, we have changed the division sign into multiplication. Don't forget the mathematical gymnastic that happens there. Once you change the division into multiplication, your denominator becomes the numerator, your numerator becomes the denominator. I always love this part. I would always refer to it as mathematical gymnastics. Now, this is the same as multiplication. I'm now multiplying negative 12 divided by 3 by negative 3 divided by 6. There we go. When you simplify this one, negative divided by a positive is a positive. How many 3's are in 12? We have 4 of them. Multiplied by there, negative divided by a positive is a negative. How many 3's are in 3? It would be 1. How many 3's are in 6? It would be 2. Now, this is the same as multiplying negative 4 by negative half. Remember, negative times negative is a positive. And 4 halves. Let's go to the answer. There are 2. Beautiful. I hope that you are with me here. Moving on, 3.1.2 now, I'm still saying calculate negative 12 minus 2 times minus 3. Please, folks, remember this. In this case now, we are multiplying there. Be very careful because there's no sign between the 2 and the bracket. Keep that in mind. Now, remember that we said when we multiply a negative by a negative, it would give a positive. And 2 times a 3 is a 6. Now, in this case, we have to bring down the negative 12 because we did nothing to it. But now, that is where we were very busy in this problem. Negative times negative gave us a positive, and a 2 times 3 gave us a 6. Now we are back into addition and subtraction. We've got minus 12 plus 6. And keep in mind, I said, when we add the integers, if the signs are different, you subtract and take the sign of the bigger number. In this case, it would be 12 minus 6, which is 6, and the bigger number is 12 there. It would give us the sign. There we go. The answer is minus 6. I hope everyone is with me. Beautiful mathematics. Moving on. Now we are going to deal with integers with squares and cubes. Now, dealing with squares and cubes, I want to go somewhere first to remind you, my beautiful friends, because I love you. I want to remind you of how to deal with sets, that is square and cube, without using a calculator. I can hear some of you panicking, saying, sir, can we do that? You're saying, yeah, we can do that. Let's take example number 1. I am finding the value of a set without using a calculator. You look at me here. Do you see a calculator? No, there's absolutely no calculator here. Let's move on. In example number 1, what I would actually be doing, let's go back to that example there. Let's go back to that example. What is happening now here? There we go. What I would be doing, I would be solving sets without the use of the calculator, but please remember this. When you have the nth root of a to power n, I repeat again, the nth root of a to power n, this is the same as a to power n divided by m. Can you see the n? It is there. The m comes in there. Beautiful. Now, what if you are given numbers to deal with? Square root of 2 to power 2 multiplied by the square root of 3 to power 2. Keep in mind, we are multiplying. Now, I'll be going there saying, you told me that if I've got nth root of a to power n, it is the same as that. Now that means 2 to power 2. Remember, there's nothing there. It means 2 would be 2 to power 2 divided by 2, multiplied by, I keep the multiplication, 3 to power 2 divided by the 2 there, which we normally don't write. Now, 2 divided by 2 is 1. 2 to power 2 divided by 2 is the same as 2 to power 1. 2 divided by 2 is 1. 3 to power 1. Now, 2 times 3 is a 6. Please note that when you are working with sets without the use of the calculator, you have to remember that rule. Now, let's go back to our examples there. We have to calculate this without the use of the calculator. Already we have done that. Now we know that this is 2 times 3 times 2 from the previous slide. 2 times 3 is a 6. 6 times 2 is actually equals to 12. Next example. Can you see that there we have a cube root now? I can hear some panicking saying, but you haven't shown us anything about the cube root. There we go. Let's solve the cube root of minus 64. Remember to always factorize that using the prime factors. 64 divided by 2 is a 32. 32 divided by 2 is a 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. I remember Putsi did this yesterday. Now we write this as the product of prime factors, and for that matter, I write it in an exponential form. We have 1, 2, 3, 4, 5, 6 2's there. That means it is 2 to power 6. Now it means where you see 64, you can actually put 2 to power 6. That is exactly what I've done there. You see, I have replaced 64 by 2 to power 6. Now it goes back there. It would be negative 2 to power 6 divided by that 3, which is minus 2 to power 2. And minus 2 to power 2 is a 4. Beautiful. Now it means where I see that, I'll just put a 4. Let's go back to that slide. There we go. We are calculating without the use of the calculator minus 2 to power 5, which means minus 2 times minus 2 times minus 2 times minus 2. How many times? 5 times. There's it. It is minus 32 divided by 4, which is a minus 8. Beautiful. Folks, I hope that you understood everything that we were doing. There's your QR code for the quiz question. And what is the aim of the quiz questions? It is just to practice so that you become perfect. Now take this moment and practice, practice, practice. I want to take this moment and say thank you, my friends. Mathematics is such a beautiful thing. We love you, mathematics. Thank you very much.